Hey, Ms. Smart here with your review for your Unit 6 test tomorrow. All right, so let's get started. So first, converting from exponential to log form. So just remembering that we have three parts in this type of an expression. So one part is the base. So here the base is 9. And then we have the exponent, and we have the answer. And basically, whatever the base is of the exponent, it becomes the base of the log. So the log base 9. And then this number, the answer, goes here. And then it equals the exponent, which in this case is x. All right? So the base is 9. The exponent is x. That's where those two values go. This one comes to the side. So for B, you should have log base 5 of D equals 2. For C, the log base M of 144 equals 2, the exponent. And for D, the log base 10 of 100,000 equals 5. Now, when the base is 10, you don't actually have to write it. You can just write the log of 100,000 equals 5. So either of those answers is correct. Okay, going in the other direction, we take the base from here, the exponent from there equals this. So the exponent goes there, this becomes the answer. Okay, so for part B, 36 is the base, 36 to the x equals 6. See, 10 is the base, 10 to the 0 equals 1. In fact, any number to the 0 power is equal to 1. For D, the base is 10. 10 to the 6 equals 1 million. All right, on number 3, we're evaluating without using a calculator. You could use your little pink exponent table, though that would be okay. So grab mine, it's right here. So for the first one, the base is 3. So I go to the 3 here, follow it over until I get to 27. This is the answer. So this is equal to 3 because 3 to the third is 27. That's the math fact I used from the table to make that happen. So I have the answer, and then describing in words or math why your answer is correct, that's this part. Okay, on B, the base is 5. So here's 5. And I'm looking for just 25, even though it's 1/25th. If I find the 25 here, the answer is 2. So kind of a couple things here. So first of all, if 5 to the second is equal to 25, then 5 to the negative 2 is equal to 1 over 25. And that's just how negative exponents work. So this is the one that relates to the problem. So this answer is negative 2. Okay, C, I know that 10 to the 1, 2, 3, 4, 10 to the 4th is 10,000. So this is equal to 4. Remember that the answer to a logarithm is the exponent. And then part D, I know this is 0 because anything to the power of 0 is equal to 1. And so D is 0. All right, for the next section, I can just use the calculator to evaluate. So for each of these, I'm going to use the change of base formula. So for A, I will find the log of 81 divided by the log of 3. I actually could use the sheet for A because 81 is a power of 3. So either way, the answer should be 4. For B, 17 is not a power of 5, so I am going to have to use a calculator. The log of 17 divided by the log of 5. And so I'm just going to use this calculator with the log button right here. Okay, so we're looking at the log of 17, close the parenthesis, and divide by the log of 5. 1.76, it says thousands, so 1.760, 3 decimal places. For C, it's the log of 200. I don't have to use a formula because I can just use the log button, 200. Since the base is 10, that's the base that the calculator knows. 2.301. And then for D, the log of 8 divide by the log of 64. So here on the calculator, the log of 8, close the parenthesis, divide by the log of 64. And we get 0.5. All right. Number 5, solve for x. Show all your work. Round answers to the nearest thousand. All right. So when you solve for x, like you want your equation to look like a and b, where you have the base and exponent by itself, so then you can switch to log form. So for a, we're going to go straight into log form. X is equal to log base 10 of 7, which is, again, when the base is 10, you can just do the log. 0.845. Okay, for b, x is equal to log base 19 of 96. So we're looking for the log of 96 divide by the log of 19. 1.550. And C, before getting started on C, you need to get 16 to the x by itself, and you do that by adding the 8 since it's currently being subtracted. So we have 16 to the x equals 68, so x equals log base 16 of 68. And so that's going to be the log of 68 divided by the log of 16. 1.522. Right round? Wait. Yeah. 1.522. Okay, number 13, or sorry, D. This 14 to the x is being multiplied by negative 3. So we're going to divide both sides by negative 3. And so 14 to the x equals, let's see here, negative 31 divided by negative 3 is 10.3 repeating. So I'm just going to leave it as 31/3. It just makes it more accurate at the end. If you rounded this, your final answer might be a tiny bit different, but that's fine. So I'm going to leave this as 31/3. I'm going to ignore the negative since it turns into positive. And so that means x is equal to the log base 14 of 31/3. And so the log of 31/3 divided by the log of 14. Okay, 0.885 if you round. All right, part E. Our base is 13, exponent is x minus 7. So I can go right ahead into log form. X minus 7 equals log base 13 of 42. So I'm going to find this answer, and then once I have it, I need to add the 7 over, right, to get the x by itself. So log base for 13 of 42. So the log of 42 divided by the log of 14. 1. Oh, oopsies, log of 13. Okay, sorry. So the log of 42 divided by the log of 13. There we go. And now I'm going to add that 7 over so that I have x all the way by itself. So this was equal to about 1.457. Add the 7 over, we get 8.457. Okay, F. Same thing, this is our base exponent. We can go ahead and switch to log form. So 9x is equal to the log base 20 of 23. So I'm going to find this and then divide by the 9 since it's 9 times x. So the log of 23, divide by the log of 20, and then divide this answer by 9. So this is the value of 9x. So divide by 9. This is the value of x, 0.116. Okay, the bottom three are all log equations, but in a similar way, you're going to get the log part of it by itself. So the first step on G is to divide by the 3 right there. So you get the log base 11 of x is equal to 1. So this means that x is equal to 11 to the first, which is 11. Okay, on H, again, we're going to get log base 4 of x by itself by subtracting this 10. 10 minus 10 is 0. So we have 4 to the 0. Base is 4, exponent is 0. And so 4 to the 0 is 1, so x is equal to 1. Finally, for I, we're going to get log base 8 of 4x by itself by subtracting the 5. So we have log base 8 of 4x is equal to 3. That means 4x is equal to 8 to the third. And 8 to the third is 512. So if 4x is equal to 512, now we just divide by 4. And 512 divided by 4 is 128. All right, let's look at some story problems. Okay, unfortunately, there's not a ton of room on the story problem pages, but we'll do our best. So write an exponential equation, then solve for each problem. So for A house purchased for $136,000 in 1990 appreciated at a rate of 8% per year. That means it gained value. What was the value of the house in 2007? So for appreciated at a rate of 8% per year, that's going to be 1 plus the 8% as a decimal, which is 1.08. Okay, so our initial value is 136,000. and it's being multiplied by 1.08. So this was the value in 1990. We have to find the value in 2007. So from 1990 to 2007 is a difference of 17 years. Okay, so 136,000 times 1.08 to the 17th is 503,202. I'm just going to use the dollars. Okay, so then this is the value now in 2007. In 2007, the house market started going down and values decreased by 12% per year. So when value decreases by 12%, that means we do 1 minus 12% as a decimal, 0.88. Okay, so if it was increasing, we add the percent to 1. If it's decreasing, we subtract the percent from 1. How much will the house be worth in 2012? So we're taking the value in 2007 and then multiplying it by 0.88. Our exponent is now going to be 5 because 5 years from 2007 to 2012. So 503,202 times 0.88 to the 5th is 265,000. That looks a little tiny bit off. Oh yeah, no, it's fine. It's just because I rounded a little bit early on this one, but it's okay. So 265,000. 500, I'm going to round to $56. Okay, so that's the value in 2012. At this rate, when will the value be equal to its original value in 1990? So for part C, the current value, 265,556, decreasing by 12% to the T. When's it going to equal 136,000, which is the value in 1990? So we're going to start by dividing both sides of the equation by 265,556. And so here's our new equation, and we just switch to log form. So T equals the log base 0.88 of 136,000 over 265,556. And I can put that all into my calculator. So the log of this, 136,000 over 265,556, and then divide that by the log of 0.88. I get about 5.2. So it's 5.2 years after this value, which was in 2012. So 5 years after 2012 will be in 2017. Okay, next. You start a bank account with $1,000, make no deposits. The account will earn 6.5% annual interest. So 6.5% is 0.065 as a decimal. So the difference in these questions for A, B, and C is just how often this is being compounded. So yearly, so once a year, monthly, 12 times a year, or quarterly, 4 times in a year. So for being compounded yearly, it's just 1,000 times 1.065 to the T. It just happens once a year. But now when it's monthly, 12 times a year, We're going to divide up the interest into 12 parts because only a little bit each time. But then we have to multiply by 12 out here to show it happens 12 times in a year. Same thing with C, only quarterly means 4 times in a year. So 1,000 times 1 plus 0.065 divided by 4 to the 4t. Now for part D, we're evaluating each of these for 7 years. So we're just going to put a 7 here. Okay, so for the first one, I'm just going to do a little squiggle after each one. 1,000 times 1.065 to the 7th. $1,553.99. Okay, the next one, 1,000 times 1 plus 0.065 divided by 12. And then our exponent is 12 times 7. Okay, a little bit more money. This is $1,574.24. And then the last one, 1,001 plus 0.065 divided by 4. And then to the 4 times 7. 1,570. And 42 cents. Okay, so these answers are for part C, or D. Okay, number 8. The population of a city is currently 45,325. It's been decreasing at a rate of about 3% per year. So decreasing means we would add if it was increasing, we subtract because it's decreasing. So our factor is 0.97. Write an equation for population. Okay, my equation, the population after time equals the initial amount times 0.97 to the t. Now we evaluate for 7 years. So 45,325 times 0.97 to the 7th. Okay. So I got 36,622. These are people, so whole numbers. Okay, and then see, when will the population be less than 20,000 people? So 45,325 times 0.97 to the t. When does that equal 20,000? So again, base and exponent, we want to get that by itself first. So divide. So let's see what kind of a number that is. 20,000 divided by 45,325. Oof. It's not a very nice decimal, so I'm just going to leave it as a fraction. Okay, so I have this here. I'm going to switch to log form and say t is equal to log base 0.97 of 20,000 over 45,325. Now, if you divided this and rounded, it's totally fine. You can totally do that. Just your answer might be a tiny bit different than mine at the end, but as long as you have the work shown to support it, it's not a problem. Okay, So last but not least, I'm going to get this value. The log of 20,000 over 45,325 divided by the log of 0.97 is about 26.9 years. I just rounded that up a little bit. Almost 27 years. Okay, on number 9, write an exponential equation to model the car's value. So it's bought for 15,000. It's decreasing in value each year. And instead of knowing like a percent of decrease, we know values in a table. So I know that the value over time is going to equal the initial amount, which is 15,000, times some sort of factor to the t. Since this is decreasing, I'm going to expect my factor to be less than 1. And so I have to figure out what you multiply to get 12,900. And you do that by dividing. 12,900 divided by 15,000 is 0.86. That's the number that goes in the parentheses. Okay, now if I divided in the other direction, I get a number more than 1, and I know that number is wrong because this is decreasing. A number more than 1 would make the table increase. So I would just, at that point, turn it around to get the right number, 0.86. When will the car be worth less than $2,000? So you have to solve the equation. 15,000 times 0.86 to the t is equal to 2,000. And again, we start this by dividing both sides of the equation by 15,000. Okay, now when I put 2,000 divided by 15,000, it's a long repeating decimal, so I'm just going to leave it like that. So 0.86 to the t is equal to this, so t is equal to the log base 0.86 of that, 2,000 over 15,000. Okay, so you can find that on the calculator. The log of 2,000 over 15,000 divided by the log of 0.86, about 13.4. So these are years, 13.4 years until the car's value is less than $2,000. All right, finally, our last one. Sarah's grandmother wants to help pay for her college education by giving her $1,000 when she turns 18. Sarah is only 3 years old right now. Sarah's grandmother has found a college savings account that will pay 8% interest compounded monthly. How much should be deposited so that Sarah's grandmother will have enough money? Okay, so we're trying to figure out the initial amount. We know the total needs to be 100,000. So whatever that initial amount is, how much should be deposited, I'm going to call it A. And then I'm going to address this part. 8% interest compounded monthly is going to be 1 plus the 8%, 0.08, divide by 12. And then we're going to also multiply by 12 in the exponent. Now, in this particular problem, we can assume that this is happening, gaining interest in the account for 15 years. And the way I know 15 years, it's for when she turns 18 and she's currently 3. 18 minus 3 is 15. We want to know what the deposit should be so that the total is 100,000. Okay? So to solve for A, we're going to divide both sides of the equation by 1 plus 0.08 over 12. 12 times 15 is 180, so I'm just going to write that. Okay, so now we are going to have A by itself. It's the answer to this. Okay, now to put the exponent part down in the division, I do have to use a couple sets of parentheses. So 100,000 divided by double parenthesis, 1 plus 0.08 over 12, and then close that parenthesis, use the power of 180, and then close the second parenthesis, and we get 30,000. I'm just going to round that to $240. Okay, so this needs to be deposited now to work in that sort of an account and have $100,000 in 15 years. So that is the end of your review. I hope you found the video helpful.